Good morning, Professor Satar. I'll be going over my quiz 3 on Christian Ruiz. So, to show that an electric and magnetic field can create a traveling wave, you start with Maxwell's equations in vacuum. Specifically, you use Maxwell's third equation, which is Faraday's law, in vacuum, of course. And solving for the left hand and right hand side, you plug in what your E and your B are, and you get these results. So equating left hand side to right hand side, you get K, you get this equation, the cosines cancel out and the negatives cancel out. But here, as defined, this is what your K is equal to, this is what your omega is equal to. And you're able to plug that in right here, from here to here. You plug it in and you're able to get them, cancel out the 2 pi's, get everything onto one side. And also defined as the speed of light, which is lambda times your frequency, and you're able to replace that with the speed of light, showing that the electric and magnetic fields create a traveling wave which travels at the speed of light. Part B, to show that the speed of the wave is the speed of light, you start by looking at equation 9.42 in the book, which is velocity equals rad epsilon naught lambda naught, which is in fact the speed of light, and the speed of light c is defined by E over b. And for this, you use Maxwell's third equation and fourth equation, and for the third equation, Faraday's law, you use the integral form, and you're able to solve for both sides of the equation, left hand side and right hand side. You equate them to each other, getting result A. Then you move on to Maxwell's fourth equation, which is the integral form, and it's the same thing as equation 3 with the addition of mu naught and epsilon naught. You use the fourth equation, again solve for both sides, and you're able to get result B. So solving for both result A and result B, we start off with A. You plug in E and your B on both sides, and you're able to solve. Things will cancel out. You're able to bring things both on one side. Here I wrote that B is equal to omega over K, which you can replace that with B. B equals epsilon naught, E naught over B naught. And since E, the electric field and magnetic field are in phase, you're able to say that the velocity is equal to E over B, not E naught over B naught. From here, we can solve result B in the same fashion we solved result A. So we're able to get the same result, except in here B is equal to omega over K. These two switched, and since V is equal to, we're showing the speed of light, the speed of the wave is the speed of light, V is equal to C, and C is equal to epsilon E over B, and so that's 1 over V, and you're able to get the V's on one side, you get V squared, and you're able to get the equation 9.42 in the book, which is equal to the speed of light, showing that the speed of the wave is the speed of light. For part C and D, showing the electromagnetic wave is transverse and B and E are perpendicular to each other, you start off with these in vacuum. You work everything out, plug everything in. Here you get your results they end up being the same for E and B, and the thing here is, in order for this to be true, K has to be 0, or else in vacuum won't be true, as I wrote down here and here. So right here, if you have E dot K equals 0 and B dot K equals 0, your theta must be 90, showing that E is perpendicular to K and B is perpendicular to K, which means that E is perpendicular to B. Thank you.